Alright, I'm going to be doing section 3.1.b. It's going to be on page 170, and it's going to be problem number 38. And in this problem, it is asking us to locate the absolute extrema of the function, if any exists, over each interval. So it's given us 4 intervals. The first interval, a, is a closed interval 1 to 4. And then the second one, B, is a closed 1 and an open 4. And the third interval, C, is a open 1 and a closed 4. And the last interval, D, is open 1 and open 4. Now the function it gives us is f of x is going to equal 5 minus x. Now first we have to find the critical points, and then find the y values, and that will give us the maximum or minimums. So in order to find the critical point, it's whenever the tangent is equal to 0 or it does not exist. So we have to find the first derivative. So f prime of x is going to equal -1. We have to set it equal to 0 where it does not exist. So -1 equals 0 just doesn't exist at all. So there's no more critical points in between all these intervals. So the only thing left for us to do is to check the endpoints when it is a closed interval, because if it's an open interval, we can only get infinitely close to that point, and we can't find the actual end of it. So to start with part A, we have 2 critical points. The x values are going to be x equals 1 and x equals 4. However, we need the y values also to get the entire critical point. So we plug it back into the original function. So 5 minus 1 is going to equal 4. So our first critical point is going to be 1, 4. And then we're going to plug 4 back in the equation. So 5 minus 4 is going to equal 1. So our second point is 4, 1. Now to find which one's the maximum, which one's the minimum, it's really simple. You just have to see which one has the greater y value. So obviously 1, 4 has the greatest y value, so 1, 4 is the absolute maximum point, and then 4, 1 is going to be the absolute minimum point. So now for this one is A. So for B, we are going to have, we only have 1 is when x equals 1, because since this is an open interval, we do not know what number to check because we can only get infinitely close to it. So when we plug 1 back into the equation, 5 minus 1 is 4, and we have 1, 4, and this one is going to be the absolute maximum because that's what it was earlier. So we move on to interval C. We have the open interval of 1 and a closed interval of 4, so the only thing we can check is 4, is when x equals 4. So we plug 4 back into the equation. 5 minus 4 is 1. We get the point 4, 1, and this is going to be the absolute minimum. And we're left with one more to check, which is D, and that's when it is open interval 1 and open interval 4. They're both open intervals, and the derivative is never equal to 0, so therefore there are no maximums or minimums, no absolute maximum or absolute minimums.